Hello, everybody. Thanks for inviting me to this incredible conference. It's a pleasure to be here today. My name is Stefan Werrlich. I'm a PhD student at the BMW Group in Munich and working in the field of augmented reality. And today I would like to present my paper comparing HMD-based and paper-based training. First, I will start with the motivation of our work, my PhD thesis. Then I will present both learning systems, so the HMD-based and the paper-based learning system, and following with the description of our evaluation. Let's start with the motivation of our work. In a previous paper, we did a literature survey in 7 online databases using the keywords augmented reality and training. And we found 1,610 papers in total, and from there we selected 136 in the assembly domain, and we analyzed them, and we found out that we have limited usability studies, and those that were conducted are mostly with students in laboratory contexts, with Lego use cases, and so on. And it's not clear how to analyze, design, and evaluate augmented reality-based learning system. So that was the base of my research and my PhD thesis, and then I developed a user-centered framework with recommendations for methods and so on for analyzing, design, and evaluate those systems. I instantiated an HMD-based learning system, and from that I evaluated and derived design guidelines. And today I want to present you my learning system, which I developed for the Microsoft HoloLens. Here on this slide you can see my multimodal user interface, which we developed through several iterative evaluations. For the design, we considered our findings from a user task analysis we performed at the beginning of our project, and findings from a literature survey. We also considered guidelines for UI design, such as the 8 golden rules of interface design and so on, dialogue principles, recommendations for gamification, and recommendations for AR visualization. And here in this user interface you can see it consists of 6 functionalities, and you can see an arrow on the left and on the right side, and the entire app is controllable by gesture interaction and by voice using the commands next and back to switch between steps and select to choose a functionality. By activating the audio symbol, users receive auditory information about the current step. By selecting the cube symbol, users are provided with a superimposition of the current part direct overlaid on the engine. The text feature shows details about the current step, such as tools and parts that are required for the current step. And maybe you know this, this was inspired by a previous work of Bioka and Björn Schwertfeger. This is our tunnel, or the AR tunnel, which guides a user to the correct box to pick up the right parts. And we additionally added a little arrow at the end of the tunnel to show the position of the box. In contrast to the first cube, which showed a static overlay, this feature shows an animation of the assembly task using an outline visualization technique. And the last feature is a video functionality. Users can observe an expert performing the task. They can also play and pause the video by selecting the corresponding button again. We further implemented context information such as a progress bar at the center of the interface and an entire overview of the complete assembly sequence, which can be activated by selecting the brand icon in the middle of the interface. Those features help to strengthen the mental model building of a user. When a person starts our application, they will find a visualization like this, so they can choose between different levels. So they can choose between a tutorial, beginner, intermediate, and an expert level, and an additional quiz level. In the tutorial level, a user is provided with all functionalities, so there's no restriction. They will get all the information to complete the assembly task. Information with the strongest guidance are then gradually reduced between each mode. So 2 features are restricted in the beginner, 4 in the intermediate, and all features are restricted in the last level. This concept aims to acquire users' cognitive skills instead of just guiding them step by step through the task. Inspired by previous work of Oliver Korn, we also implemented gamification elements to motivate the workers during their training process. This little robot you can see on the screen, named Embly, it comes from assembly, we named him Embly, provides users with auditory feedback and joyful animation at certain tasks or at the end of a procedure. In contrast to that, Embly loses one of its 7 lives as soon as a user selects a restricted feature, because they have to learn it before and then they go on in an advanced. And if they need a restricted feature, they can click it and they will get the information, but Embly loses then one of its 7 lives. And this is how it looks like in augmented reality.
Schritt 8. Montieren Sie bitte die hintere untere Abdeckung.
And it's in German language, sorry. So here you can see the overlay direct on the engine. When you get closer, it becomes transparent. It helps to assemble the part, because otherwise the superimposition is so strong. Select. You can control the app by saying select. And the interface stays the whole time above the engine, doesn't move.
Bitte entnehmen Sie das Bauteil aus dem Regal.
There you can see the tunnel with the indicator to the right box. When you get closer, you get feedback.
Gut gemacht. Entnehmen Sie nun die zugehörigen Schrauben.
Then it switches to the screws.
Sehr gut. Entnehmen Sie als nächstes den passenden Schrauberaufsatz.
And then you can pick up the tools and then you have everything to assemble the part.
Hervorragend.
There you can see the animation with the outline visualization technique. This is really good for assemble the part, because then you see the contour of a part and it helps to select it, because the overlay is not too strong. And then the last feature is the video observing the expert. And so a user can select 6 functionalities for one step, and they can choose on demand what they want. And then they can assemble. I will stop this, and this is the additional level. So if they complete all levels, they can use a quiz mode, and they are asked to select the right parts, and then they fly to the engine. So they assemble the engine without physically assembling it. So they choose the right one, and assembly makes happy and joyful animation.
Was hier montiert werden soll?
So also screws are necessary for that step.
Schritt 8. Was benötigen Sie hier?
And here you can also see occlusion on the engine. And
Schade, Sie sind leider durchgefallen.
if a user selects the wrong part, it starts over again, and they are allowed to assemble the real engine only if they finish all level and then the quiz, and then they can go on and assemble the engine without any support. Following the HMD-based learning approach, we designed the paper-based instruction, ranging also from tutorial to an expert mode. We printed the instructions single-sided on an A4 sheet of paper. Therefore, each instruction contains 15 pages according to the number of assembly steps. Here you can see we implemented detailed pictures with the parts that are necessary, text and so on for the tutorial, and then we gradually reduce it according to the HND-based learning system. In the beginner, less information; intermediate, less information; and expert, only the description of the task. Let's come to our evaluation. We compared both solutions and conducted a summative evaluation following a 5-step method. For this, we defined a user task, this 15 steps user task, and then we compared both solutions by evaluating them with 15 participants in each group. During the studies, the evaluators collect qualitative and quantitative usability data. We had 2 phases. So first, the training phase and the recall phase. So in the training, they completed all levels, and then the recall without HMD and without paper. During the training and the recall, the evaluators observed the participants and measured assembly mistakes, picking mistakes, and so on, and they measured the time. And afterwards, we conducted semi-structured interviews, and we used standard questionnaires such as the NASA-TLX system usability scale, user experience questionnaires, and so on, to measure the pragmatic and hedonic quality of both solutions. In contrast to many other evaluations with low Lego Duplo task, we use a real engine assembly task with 15 steps and a real work environment corresponding to that you can find in the production. You can see here a driverless transport system with a 6-cylinder engine, a tool area, and a shelf area. So a trainee has to walk around all the time, pick up the parts, and assemble it on the engine. We acquired 30 trainees for that studies, 27 male and 3 female, through asking the BMW Group Education Department in preparation of our study. They were all trainees in the 2nd or 3rd year of their technical apprenticeship, and they were between 15 and 25 years old. Both groups had medium experience with assembling and no prior experience with using AR before. Let's come to the results. We found significant difference for the completion times. Group 2, so that group who used paper-based instruction, completed the entire training, so all levels 47% faster compared to group 1, and also you can see each level, so they completed the tutorial level more than 50% faster, and so on. And also in the recall, without any support system, they completed 15% faster than the HMD-based group. Let's have a look at the quality of the training. We also found a significant difference for the mistakes. Participants who received HMD-based learning made 62% less assembly mistakes during the study, and also 77% less corrected assembly mistakes during the study. After completing the training, they had to assemble the engine again without any assistance, and the group who received HMD-based learning made 83% less sequence mistakes compared to paper-based. So the quality of the learning is much better than the paper-based learning. Let's have a look at the system usability scale. For the HMD system, we got the system usability scale of 91, which is really high, so it's between excellent and best imaginable. And for the paper, we got a scale of 80. But both systems are above average, which means 68. So they are both sufficient for assembling an engine. We measured also the NASA-TLX and found significant difference for the mental and for the temporal workload. Participants who received the paper-based instruction had a 32% higher mental workload and a 49% higher temporal demand. Let's have a look at the user experience questionnaire measuring the pragmatic and hedonic quality. We found significant differences for the HQ and for the overall quality. For the HQ, we found 72% higher score for the HMD and also for the overall 41% higher score. This is my last slide. Asking the participants about their meaning about both solutions, they stated about the HMD that the UI is very simple and provides them information. They prefer voice interaction because it allows them to work hands-free, and the video helps them a lot to understand the task, so it's one of their favorite feature, but they really like the AR tunnel because they said the visualization is really cool and also the feedback and so on. And they stated that the robot is really cute and very funny and makes them smile because of the joyful animations and so on. But what is not so good, and I think we should all work on the improvements of the HoloLens. They stated that the gestures feel unnatural and they look kind of stupid. So we need more natural gestures. And also the superimposition was not so good, but was enough to understand the assembly procedure. And of course, they wear the HoloLens for about 15 minutes in the 50 minutes in the tutorial, so it becomes heavy after wearing it for a while. And participants from the group 2, paper-based, stated that the pictures are really helpful, and one said, which was surprising, that they would prefer the paper-based learning because it allows them to finish the entire task really fast. But they also stated that it's uncomfortable to carry it all the time while assembling the engine, and it was hard to remember the position when there was no pictures anymore in the instructions. So hope you enjoy it. Thank you very much.